Good morning, everyone. Myself, Dr. Navarisam, Assistant Professor at the Department of Food Technology, Hindustan College of Engineering and Technology. So today I'm going to discuss about the importance of analytical instruments and their techniques in food analysis. So these are all the contents I'm going to discuss in this fine morning. So first of all, what is food analysis? It is a method or protocol to find out the properties of food and also their constituents. So which product can be analyzed? So all the food products including raw, processed, semi-processed and so on. By doing so, we can get to know their composition, their structure, physicochemical properties and also sensory attributes. So it will be more helpful in the labeling requirements and also to find the product quality, the nutritive value and also whether the product is get adulterated or not, and finally it will be helpful in the research and development. There are some criteria while selecting the instruments for the food analysis. They including precision, reproducibility, accuracy, simplicity of operation, speed and cost of instruments, sensitivity and specificity and also nature of food matrix. Food analysis may be either qualitative or quantitative. Qualitative analysis provides the information about identification of some compounds or analyte which is present in our food matrix, whereas quantitative analysis provides the numerical information about analytes which is present in the food matrix.
The very first is chromatographic techniques. Chromatography is nothing but a process by which solutes or compounds that are separated by their differential migration in a system. That system consisting of two or more phases. One is stationary and another one is mobile phase. The separation is based on their adsorption, solubility, vapor pressure, molecular size or density, and also by position. A chromatographic technique typically classified as two. One is gas chromatography and another one is liquid chromatography. GC is nothing but gas chromatography which is used to separate volatile organic components and also which is used for separating as well as analyzing the compounds that are vaporized without any decomposition. So here is the schematic diagram of GC. There are various types of detectors that are used for the different applications which including flame ionization detector, electron capture detector, nitrogen phosphorus detector and also thermal conductivity detector. GC has wide range of applications which including identification of cholesterol, fatty acid profiling and also trans fat analysis. So some of the bioactive compounds which including antioxidants and preservatives can also be identified by using GC. And analysis of residual pesticides and also environmental contaminants can also be done by using GC, and we can also characterize the flavors and some of the fragrance of food materials. By doing so, we can even find out the particular oil by using the GC. Another one is liquid chromatography. So based on the process, it is classified as adsorption liquid chromatography, which is used for liquid solid separation, whereas partition liquid chromatography used for liquid liquid separation, and ion exchange liquid chromatography also there, and also size exclusion LC, thin layer LC, and HPLC is nothing but high performance or high pressure liquid chromatography, and the last one is paper chromatography. HPLC is one of the superior analytical instruments because it is not only used for the identification but also for the quantification of analyte or compounds followed by the purification. So it is used in biochemistry, analytical chemistry and also in food analysis. So that components can be partitioned or separated between the adsorbent and solvent. We can say it is a stationary phase and the mobile phase. This is the schematical representation of HPLC technique used in the industrial applications. In such a way, there are two kinds of HPLC system. One is normal phase and another one is reversed phase. And there are also some of the detectors that is used in HPLC system, which including UV, RI, F, PGA and MS. HPLC has even more application than that of GC, which may including profiling of amino acids, peptides and proteins, and also quantification of lipids, alcohols, even carbohydrates in some of the food compounds, and fat soluble, water soluble vitamins and carotenoids, and so on. Then what is hyphenated technique? It is nothing but the combination of two techniques, maybe a chromatographic technique and the spectrometric technique. So the common example is nothing but GCMS and LCMS, which is not only used for the quantification but also for the confirmation of particular analyte in food mixture. So here I would like to tell you some of the spectrometric instruments that are widely used in combination with chromatographic technique. They are AAS. It stands for Atomic Absorption Spectrometry, and then ICP OES or MS. It stands for Inductively Coupled Plasma Technique, Optical Emission Spectrometry, mass spectrometry, and NMR is nothing but nuclear magnetic resonance spectroscopy, and the last one FTIR, which stands for Fourier transform infrared spectrometry. So these are all the variety of instruments used for the analysis of food materials based on spectroscopy. I have some of the references which will be more helpful for you, and thank you one and all for your kind attention.